Okay, people joining this live stream, we are doing an incremental language development meeting that I guess is working on things for version 12.3 of Wolfram language and beyond. So, variety of things. Revised base themes.
Yes, so this is a notebook that Chris sent after our meeting
these
yesterday.
look a lot better.
Yeah, it's ones that I sent Chris this morning.
Oh, I see. Okay,
And
so
these look great, Tim. I mean,
okay. And if you click previous, you can see what the previous one looks like.
No, I don't want to see that. It was horrible.
I just really toned them down and got rid of the bold text and it lists up there what I did.
Has Jeremy looked at these?
No.
Yeah, I think these titles are a little funky, but the look is vastly better.
Yeah, I'm going to be changing with the next plot theme. I'm going to be changing web, marketing, business, and scientific.
Right.
And come up with new names and
right. But I'm telling you, Tim, I think what you should do, you've been designing to those names. I think you should leave those names and fork off another name. Okay.
Right. Yeah.
And maybe that other name will be largely informed by what you have from these things, but not completely.
Yeah. Okay.
Okay.
And these are just mock-ups. The like the text, the item text is all black. And
well, that's good.
If Chris was going to change that, because I think that's why those looked so bad yesterday, is because the item text was gray.
Well, right. He needs to change that if he can. Is Chris here?
I don't. No, he's not.
No, he's not here.
But they just let him know about the meeting at 1, so.
Okay.
Right.
Okay. Looking good. All right. What's next?
Well, nothing more in relation to dataset, Tim?
Well, I don't know. I mean, there's a lot to do, but I think in terms of getting this version out, I think this is looking fine.
Okay. Well, yeah, I was asking them. So if nothing else about dataset, then they both can leave if they want.
Okay.
Okay, so the next thing to do is, as usual in the last moment in a cycle, is knitting. So we have the non-tree functions, for which we have already done the basic see also knitting in both directions, including from other system functions, but we have not added them yet to guide pages.
Mm.
And then we have tree, for which we have the collection of new symbols, which are 28, and 4 new guide pages.
Okay.
And in this case, we have the symbols linked to each other, but they are not yet linked from anywhere else in the system. And because they are so experimental, perhaps we should leave them like that in this first version.
I'm sorry, what? Leave what?
So the fact that, for example, graph functions do not yet link to the tree symbols.
Well, do they connect to them?
Not yet. So the tree symbols link to the graph functions, but not vice versa. So it is that this project is highly experimental. So I don't know what's the right level of publicity we want in this first version.
What do you mean by highly experimental?
Well, the functionality works, of course, but for example, visualization is not yet as good as it should be.
We did fix the basic styling, yes?
It has the proper colors, etc., but sizes are still not good enough. So things like nodes will overlap. Very small trees will have padding around like graphs do, etc.
Okay.
Do you want to have a look at some
just
pages?
One second.
Perhaps?
Just one second. Right, let's go ahead.
Yeah, so yeah.
What should we look at?
We could look at some pages or do the knitting of
Okay, let's do this basic knitting here.
Yep.
Okay. I have no idea what's a comparable for this one.
For lexicographic order, we could compare to alphabetic order and numerical order.
Okay. Which is, so would this be under, so that's only under string operations.
I see. So this should be, the equivalent should be list manipulations. Yeah, we don't want
Right.
lexicographic order in string.
Okay.
It does work. So we decided that lexicographic order on two strings will convert to the list of their characters.
Okay. I have to make this bigger, but let's just find whether it belongs here. Well, it's probably be rearranging and restructuring lists, right?
Yeah, exactly.
Okay, here we go. Alphabetic sort, numerical sort. Okay, let's make this bigger. Okay, so what do we got? We've got lexicographic sort
and lexicographic order. So perhaps we just add them to the list of the sort functions.
Yeah, but we've got reverse sort by here. Oh, I'm sorry. We've got the ordering functions. Well, where are the order functions here? Right, these are order functions, not sort functions, right? Oh, they've got lexicographic sort.
Yeah, it's always a pair.
Okay, so we should add lexicographic sort right here.
Exactly, yeah, I think so.
Okay, so then we've also got numerical order. Wonder where that shows up. Weird. Okay, numerical order is showing up there, and alphabetic order. Well, where do we think lexicographic order should show up?
Yeah, it's interesting. Apparently, we don't have an order guide page. We probably should have one.
We probably should have one, right? Because there's all kinds of sorting and ordering functions.
Indeed.
Where would it hang off? Perhaps off here.
Yes, I think so.
Ordering in lists. Oh, no, it's a tutorial. Never mind. Ah, boy. Okay, where is order covered? Is order on this page? It's not useful. Where is it? I don't understand. Where does the order function, what guide page does the order function appear on? I am very confused here. Oh, wait a minute. Well, let's look at alphabetic order. See, alphabetic order is just going to show up on the pages that are about alphabetic.
We have one guide called testing expressions. But it's
Okay. Is that relevant to this?
well, it contains order. And actually order is marked there as primary. So it may be.
I see.
Yeah, I hadn't realized. We certainly need I think that's something I mean, I could try to suggest for next week.
Okay. Well, here, let's understand where to put this. Why the heck is order even on here?
At the very end. Right under the red 12.2.
Well, maybe we should list here. Let's list all the orders here. Lexicographic order, numerical order. Is it numerical order, right?
Yes.
And alphabetic order.
Right.
Okay. Okay. Right. What else are we doing here? String take drop.
Yes. So these should go either string manipulation or string operations, or both.
Okay. Well, let's look where string take is. We should be using our own technology for these searches, especially since this doesn't seem to work. Help! How do I find this? I don't understand what this is doing.
Yeah, I mean, I usually like to do these things with you because this tool works so well. But I can see a string take in both string manipulation and string operations.
I think I just had to restart this, and now it does better.
Oh, okay. Okay.
Well, I don't know if it really does better. Let's see, guides. String manipulation and string operations. Okay.
Mm-hmm.
Okay, let's take a look at string operations. We got string part, string. It feels less important than string.
Yes. I mean, we have string take and string drop there, but here it could go with a pair. We could put a triple there.
Yeah, all right. I don't know how to get this to work, actually. Okay, somebody's got to fix that.
Yeah, I will fix that.
Okay. All right. Now, do we need to put it in the other place here? I think we should, because there's sort of a complete list of string operations.
Mm-hmm. Okay.
Okay.
And then there is number digit.
Okay. Which is, so that goes with integer digits, and it also goes with all the number theory stuff and so on. I assume you've got the cross links from integer digits and so on.
Right. Yes, we did.
Well, there's a whole one on number digits. And let's pull up number digits, representation of numbers, number theoretical functions, integer functions.
Oh, it's not. I mean, is it interesting for number theoretic or integer functions?
I think so. I think it's a thing people, okay, let's start with number digits, okay? So, it's digits, real digits, from digits. So, we should probably describe this so it gets the nth digit of a number, right?
The power 10 to the n.
Okay.
The digit of the power 10 to the n.
Let's put it here. Okay. Objections to that? Seem okay to you?
Yeah, perfect.
Okay. Digit representations, it really definitely goes here. It goes there as number digit. Actually. Yeah, I think it goes there. Okay.
Okay.
Representations of numbers. I think we should put it in here. Okay. And integer digits, does it go here at all? Digit related functions. We've got so many places where we talk about digit related functions.
Right.
I kind of think in this collection, it probably goes before digit count. Okay.
Okay.
All right. We did our knitting there. Okay, let's keep going. Okay, what's next? Tree.
Yes. So as I was saying, I'm not sure the level of knitting that we want to do in this first iteration.
Well, let me see the pages. Where
Yeah.
I mean, why don't we link, even if we don't cross-link from every, we should at least do a see also from the whatever it is, guide pages, from the graph guide pages to these guide pages.
Mm-hmm. Okay. So if you want to have a look at, I don't know, tree itself or something like that. So most of the functions we have in this first iteration are the structural functions, like the extraction, tree extract, tree size. So we have implemented the new greenish color.
Yeah, let me just look at these. I'm just going to, so I need to run this on the 12.3 head branch.
Yes, but it doesn't yet have the green color. You will see the.
How about in the prototype branch?
The prototype has the green color.
Okay. Okay, let's see. Ag. Prototype is taking forever to launch. Is it? Hello, prototype, application not responding. Okay, it finally did. Okay, magnificently green. Almost like that Kermit the Frog thing. Anyway, never mind.
Do you think it's too much?
No, I don't. I think it's okay. I think these are a little bit inelegant for some reason. I think that, let me just, so if I make an expression,
Mhm.
and then I say expression graph, no, expression tree. Oh, wow. Okay, that's cool. That's nice. It's much better than tree form, isn't it? I mean, we should turn tree form into this. I think the only thing I'm having a hard time with is the heaviness of those borders, which I don't remember.
I don't know the history of that. What do you know about that, Ian?
Doesn't look right to me.
I can take another look at it.
Could you check that it follows the spec? Because I don't think it's right.
Okay.
I'm just curious what happens if we go much bigger here.
Right. I was actually thinking that this was a fortunate case.
Okay.
If it is very big or very small, then I think, yeah, it has more of that type of problem.
And what determines the overall aspect ratio here?
What about graph plot does? So this is based on graph plot internally.
Right, and I believe it's right. I believe it's automatic, right? It lays them out, and then depending on how wide versus how tall your tree is overall, that sort of, right? You can see that it's keeping layers straight. So it's how many layers versus how wide they are that determines the aspect ratio.
But so if I were to say expression tree of this, and I were to say an aspect ratio here, does that work?
I don't think it does.
No.
No. We don't take visualization options yet.
Okay. Okay. So you probably should. And I mean, in this case here, the overall size is pretty goofy too. I don't think you probably thought about that. I mean, this is probably the default overall size.
Yes, but basically here everything is default. We have tried some heuristics, but it's very difficult to get always right.
And thus far the heuristics are doing things like cutting things off. So I think it's better to have something that's squished that you can make bigger than.
Oh, sure, yeah. But I guess my question is, doesn't graph have a heuristic based on the number of nodes in the graph for what the overall size is? This should do something like that.
I think it does, but here we have the added problem of the labels of the texts. And that's hard problem. I mean, it's the same hard problem we have in Geo, having to worry about collisions, etc.
I understand. But at the very least, we could get some. I see what you're saying. So if you say, how do I get rid of all the labels here? Is there a good way to do that?
Do tree map null ampersand. Yep.
Okay.
Right. And I think the issue is that graph assumes each one of those vertices is a small dot. And so it picked a good size for that. And it doesn't know about the labels overriding.
But I mean, I would like to turn this into a pure tree in which there's no, in which there's no actual payload anywhere. Right? How do I do that? If this was a pure tree, these things would just appear. No,
that's what you have.
It's not. These things here should just be dots.
Well, then we can change the shape of a vertex that contains null. But that's what a pure tree is. It's a tree where the data is null.
I thought we had a different design for the case where there is nothing at a particular vertex.
Do you mean graphic design?
Yes.
I didn't follow this enough to
don't remember.
know whether that's true or not. But
Okay. So I'm pretty sure I remember that we had a version where there was just a pure dot here. And
we
similarly here.
I mean,
we can ask Billy.
Okay, fine.
but I mean, I think you are sorry. I think you are referring to a design in the previous iteration long ago. I mean, I don't think we have discussed that with Ian, for example. But certainly we can.
Yeah, I think we should do that because I think this should be a pure tree with just dots, basically, just like graph nodes.
Mm-hmm. I remember we also discussed the possibility of, for example, having that special dot when it is list. So it's a very frequent case in which you have a list. We kind of.
What kind of list?
When we have nested lists rather than having a head list. I'm trying to think when we have discussed having a dot. And I remember you suggesting that the representation of list could be a dot.
I didn't understand where lists show up here at all. I mean,
so if we had nested lists, imagine something like groupings, in which there are many lists.
So let's say I say 1, 2, 3,
yeah.
F. Whoops.
No, they should say 2 or 3 or something. 2.
Oh, 2, yeah.
Right.
Okay.
So here we have all these nested lists, and rather than representing all these things with so many lists.
So if I say expression tree here.
Right, exactly.
Oh,
so
boy.
You see.
Oh yeah, that's horrible.
So I think you're starting to appreciate why Jose called this highly experimental.
Yes, the visualization part is certainly the part which is most lacking.
Okay. So in this case, I mean, if I somewhat bizarrely in %12, I just replace list with null.
Oh, that's a bug.
Yeah. Ian, did you get that?
Yep.
Okay. So expression tree of 12, and I say tree map of your null ampersand trick. Yeah, that's pretty horrible. That really should be just small dots.
Mm-hmm.
I mean, it'll look lovely when it goes to full size, but it looks wrong right now.
Mm-hmm. Right. Yeah, so sizes are an issue, both on this side of the very large and on the other side of the very small.
You mean a tree that is just?
Yeah, just do tree of, something very small. Right.
Yeah, that looks wrong too. But I mean, we got that right for graph. So Ian, you should be able to get from Charles the heuristics that they've used for graph to avoid that case, right? Because if I make the graph a graph like that, that's wrong.
If wasn't this just changed
doing
to
whatever graph
documentation?
does by default.
Yeah,
That's wrong. Graph is supposed to be smaller by default for a case like that. I thought we'd managed to get that right. That's another thing that needs to be looked at, okay?
Mm-hmm.
Because again, if I resize this, I'm resizing both the overall size of the graph, and that is resizing these dots to be smaller, and it should be this size of dot in this overall size of graph. And by the way, notice you've got a slice off there.
So as I was saying before, we inherit all the problems that graph has, plus all the issues related to labels. For example, the fact that we will have to compute sizes of all these boxes like we do in Geo.
Yeah, I understand. Ethan on our live stream is pointing out that trees need collision detection, which isn't hard. Yeah, it's a lot easier than it is for general graphs. And it is true that, I mean, we have, I mean, you know, the algorithm is obviously, you know, the algorithm coming up from depth first, you know, coming up from the bottom of the tree is not difficult to accumulate that, but the tree will not look as nice. In other words, if we take a tree like this, right, it's not completely obvious what you want to do in terms of the angles and so on in the case where you are simply maximally avoiding. I mean, you're just going to accumulate. I guess this is a, yes, we do need that. We do need that. I mean, at what point do we know how big these things are?
Well, the very first thing is computing the size of each object. And this is the difficult thing because we have to take into account the fonts, the styling. It's the very safe thing in Geo. And it's the part that takes the most time because the front end is not very friendly in reporting sizes. And so we have to rasterize and do things like that.
Right. Although, I mean, there are improvements to current value, to absolute current value that are, some are in 12.3 and I think some are still coming, which may or may not help. I'm just saying that the front end is working on that aspect of it.
Right. I mean, the issue being we just don't know how big these things are until we actually know the pixelated font rendering, which depends on the platform, which depends on the front end.
Right. And so many parameters because style, we can put styles around all these things and they will all affect.
Right. Right. Let's see. There's a comment from Dan. Again, I can't parse these names properly, but Dan ... Notice that shortest path function doesn't have a summary box. What is shortest path? Where is shortest path? What is that? Looks like it's a, oh, you mean, oh, I see what you're saying. That's interesting. That's a good point. Thank you. That's a good point.
Is that, well, that may just be an oversight, or is it documentation that hasn't been reevaluated recently?
Well, let's find out. It's an oversight.
It's an oversight.
Thank you very much. Go fix it. Yeah, terrific. Thanks. How did we miss that? Or what process would have caused us not to miss it?
Well, what version was this new in? If it was new before,
sorry, go ahead.
If it was new in
version 8.
New in 8. So that means it was listed in my original list. So my hunting around and asking people somehow failed to produce this. So that's how it was missed.
Okay. Well, you know, one thing we could do, if we search the documentation for the horror of, you know, wait a minute, this is find shortest path. Sorry, shortest path function. 2010, 8.0. Okay. If we sort, if somebody, maybe we can ask the documentation team to do this, to just search for this abomination.
Well, except that's not the only possible abomination, but it's easy enough to search for such things.
Okay. Anyway, well, thanks to Dan there. Okay, let's see. Comments from Ethan about annealing and constraint-based optimizers can handle laying out trees with arbitrary sizes labeled. Yeah, I don't think we have a problem. The problem is just determining the sizes. Once we know the sizes, I think we can manage it. Do we agree, or is there a I mean, I think we were able to do it for the much more complicated case of geo layout, correct?
Right. Yes. So,
yeah. So it's just really a question of getting the sizes.
Yeah, we can program the algorithm, but what's taking the most time is the computing the sizes.
Right. Okay, so what are we going to do with trees? So basically what we're agreeing, it looks like we could have trees. Hold on, let's consider the following possibility. Where is it? I mean, the possibility would be to actually have, you see, eventually we're just going to want a thing called trees here. I would think a top level link called trees. Do you agree?
Eventually, yes. I'm just asking whether right now is the best time to do it. I mean, perhaps Charles and Roger would have to.
Right. And
comment.
But how else are we going to link it?
I'm not sure. That's why I was suggesting that perhaps this very first version, we just don't have them here.
Well, we'll never be able to find them then.
Well, they'll be in the new features. They'll be,
Right.
If you just search for trees, you'll find them.
Right.
All right. Okay. Look, put them in the related guides down here, but we need to not forget that we're goofing this up. You know, once they're ready for prime time, we need to make sure they're properly promoted here. And as I say, we definitely need to have a trees section down here.
Right.
Okay, fine. All right. Comment on our live stream from Andrew. Would it be possible to create an operator similar to @ and / that would instead by default pipe into the first argument, requiring only additional arguments to be given? Okay, for example, I see. Let's take a look at this. Interesting. All right, let's take a look. So the thought here see, the problem is anytime it looks like this, anytime we actually have a thing where it has the wrong number of arguments, I think we're toast in effect. The operator form, well, okay, so
Right. I mean, that's you just do / pound and put an ampersand at the end, right?
yes, but well, except for the precedence. By the way, I just want to report that this raft is having its bottom cut off. Yeah, frame cut off.
Right, but the precedence works in that case. The precedence is completely correct for that case. I do that sort of thing all the time.
So what are you saying?
In the 1, 2, 3, 4, 5 / put a pound, put your second arg, and then ampersand.
Right, that precedence will work fine.
So I'm not sure why we need a special operator for this.
No, I agree. This works. But now, does it? And if you want to pipe it, I mean, clearly, if you want to, it'll keep piping, right?
Right.
Yeah, I think this can work. I mean, I think the only thing that I could sort of maybe conceivably imagine, but I don't think it makes sense, is an auto functioning thing here. But I don't think it'll make sense. I think it'll be a mess. I think it'll be too hard to understand when it's going to do that. So I would say I think this is in fact working.
Operator applied could be also used. / operator applied of f of 2.
Okay, let me just understand that. So right. So the issue here would be if operator applied.
So this works because precisely operator applied by default considers that what follows is the second argument.
No, I understand that, but it's just structurally, I mean, I understand the goal of being able to pipe through a bunch of functions. And the fact that it would be nice if there was a syntax that made that really clean. I mean, like you know, in a perfect world, you would be able to say, you know, slash slash, let's say, you know, slash tilde f slash whatever, 2. Oh, but it's not obvious what's going to happen here. It's not obvious that's the second argument. Well, an interesting thing. Okay, we could add this to things that we might think about argument connection. I mean, I have a much grander scheme for these kind of non-deterministic argument connection, which still has to be worked on. By the way, Ethan is commenting again that tree layout is slow because of the front end. We're not saying it's slow. It won't be slow. It has not yet been implemented just because it requires complicated plumbing. Suggesting using NetTrain as an approximator for the bounds of styled expression. That is sort of an interesting idea, which I don't think we've explored. Although I mean, I don't know whether that's kind of. I don't know whether we need to, because I think it is quite fast to find the actual sizes. Is that true, or is that not true? Is it worth having an approximator that works without having to go to the front end?
It depends how many cases. For example, I mean, it takes milliseconds at most for one individual case. But of course, in Geo, for example, we have maps with thousands of labels, and then we don't want to wait seconds.
Well, I wonder whether there is an interesting play for NetTrain there. It's an interesting idea. We haven't considered that. I mean, where basically you run, I mean, actually, it sounds like a really quite good idea. I mean, we run a few tests in the front end, right, to say how big are these things showing up. Okay, great. I mean, maybe we have a network where we say these are the tests we ran, and we have a pre-trained network where we feed in those. Maybe it isn't even the network. Maybe it's just a pure statistical type thing where we feed in those values, and we just probably end up being a network. And then we say, I mean, maybe the way it works is we do a probe of, you know, here are, it's kind of like an interesting kind of, you know, reinforcement learning type story. You know, we find what the optimal test words are to ask the front end, how big are these things? Okay, we've got back the results for 20 test words, which takes, you know, which can happen, you know, which can be cached in a session. Then, given those results, we can then compute how big any given word will be. Sounds like a pretty good idea to me. Does that make sense to you?
We can try, certainly.
I think it's a good idea. Thank you.
I have to dash to another meeting. Sorry.
Okay.
Okay. Thank you.
See you. Okay.
Okay.
Let's see. There was. Ethan is saying it really is very doable. We'll try it. Thank you. Thank you for that suggestion. Appreciate it. Okay.
Okay. So this is I mean, we always discuss at the end of a cycle.
I love this. Steve is asking, is Wolfram language for ARM coming? Yes. Yes, we have versions running in-house. I think is it in 12.3? Do you know?
It's a pity that the guy left because he knows all about that.
Okay, sorry, wrong people.
As far as I know, yes. All the
I know what it is. I know what it is. I know the chain of dependencies. The issue is there are some trailing things like the machine learning framework that are not native. So you can run under the emulator, Rosetta or whatever it's called. That's fine, but there are a few trailing pieces that are not yet native. And unfortunately, you can't make an application be native until everything is native. And there are, as I say, still trailing pieces, some of which are actually quite hard. But it's coming. And RPS was asking and wondering if we should have a stream every month dedicated to simple programs exploring their technicalities. Yeah, well, I love that stuff. And we haven't been very organized about that. And it would be an interesting thing to do. And that's for, again, a different group here. And thank you for the suggestion. Ethan is posting some things for tree layout, which we should look at. Thank you. Okay, let's have a quick look through this list of objectives here. Okay, so around got in its speed improvement for 12.3, right?
Correct. Yes.
Wonderful.
And yeah, like a couple of orders of magnitude. And
well, that's spectacular. Okay.
And I mean, in generic numeric computations, it should be specific. So.
Right, but I mean, so my question there is, I mean, clearly for around, the future is making sure that it works in all the statistics functions and things like this.
Mm-hmm. Yes.
But that's probably not that's not the ILD team.
Exactly. Yes. So that should be implemented by the statistics team.
Right.
So my interest now to continue with around is to make around itself more powerful and to cover the important things that doesn't cover yet. And users have reported these missing bits.
Okay.
So
complex numbers sounds like a messy, complicated thing, but sounds necessary. Do we understand what the display would be like?
So here the idea is that right now we are essentially using boxes of error, like it's like a linear error in real part and error in imaginary part, and what users want is an ellipse. So there is correlation between real and imaginary part. So what that will require is that the second argument is a matrix.
I don't understand. For a complex number, if I say 67 plus 22i,
right,
then what you're saying is in the complex plane, you want this to be, so, and if I say something like
right now you can say around and output 5 plus I, something like that. And the system can handle that. So in a sense, what this is doing is having a box, a square box, rectangular box of error.
So what happens if I say complex list plot of this?
I'm not sure this is going to work. No.
Okay.
So, but this is because the function is not...
hold on, actually, yeah. I didn't give it a fair chance. Okay. Yeah, go ahead.
Yeah, so the problem with a box description of the error is that if we multiply by a complex number, the result is not going to be the rotated rectangle, which is what it should be.
I understand.
Right?
Is it going to be the rotated ellipsoid?
Once we have ellipses, then we can rotate the ellipses, and then it will work correctly.
So in other words, the ellipse is specified by its major axis and its eccentricity or something. Is that right? Or it's semi-major axes? Semi-major, semi-minor axis.
We need three numbers, which usually are represented like the three numbers of a symmetric real matrix. Because this is via correlation.
Really? So, I mean, okay, we're thinking about it in terms of correlation, but if people are just thinking about it as I'm a little confused. But I mean, this business about combining matrices and error ellipses, don't we already have that issue?
We have it in vector around. So if we have a 2D vector around, the problem is already there, and we can handle it.
Okay, so it's a question of porting the vector around stuff to complex numbers. Is that right?
Exactly. Yes. Exactly.
Okay. And I mean, so in vector around, do we do the plotting correctly for vector around?
Yes, we do.
So how do I do that?
Let's see, what's an example? So you would need a vector. So what's an example here? I guess in the list plot.
This, by the way, is a bit of a lame page, if I might say so. I mean, it probably should show the list plot.
Yes, yeah, we can do better. I think in the list plot page, there are examples under interval markings.
The heck is that?
List plot.
I don't understand that at all. So let's see, vector around is a two-dimensional vector.
Right.
So that would be this position 1.8, 2.4.
Yes, and then the 0, 3, 0, 4 are the errors of each one, and the 0, 5 is the what's called the correlation factor, which represents a matrix. Now you have to give either a matrix or that notation, which is a pair and a number.
Okay, so if I give a matrix here,
A symmetric matrix. So change the and it has to be a correlation matrix. So the non-diagonal numbers must be small.
okay, all right. So 1.2,
Right.
0.21.
Correct.
Actually, let me make it just like 0.3 or something. Oh, you said a symmetric matrix.
It's symmetric. It has to be symmetric. Yeah.
A lot of constraints here. Okay, what does that mean? I see that's got little tentacles that have, I don't understand what this means.
I see. So what this is representing is the axis of this ellipse we are talking about. So
I see. Those are the semi-axes.
Do interval markers go to ellipse? I think it's called. Ellipses. Yeah. Exactly.
Oh, nice. Okay, but so what should we be doing by default? Because I mean, the other one is what we think we're doing. The other one because we're trying to make it look like standard error bars.
Right.
Which is probably a mistake in this case, and it's definitely going to be a pretty confusing thing for complex numbers if we see that.
Yeah. So this is probably a discussion with Brett. What should be the defaults for these cases?
All right, but anyway, complex numbers sounds like that's not super hard because it's just porting over the stuff from vectors.
Correct.
Okay, confidence intervals. What's that about?
Yes. So this is right now when we say a round of 3,3, it's always meaning the standard 1 sigma. Now, users will want to say sometimes these 0.6 corresponds to 3 sigma, 2 sigma. Right?
I understand.
And so this is a bit like, this is a mixture of admitting a more general input and also the representation. So that I'm not sure yet how to do it, whether we would just do the computation to convert the input into a single sigma.
So I mean, the question is, if this was the 2 sigma bound, right?
Right.
You might want some notation that said 2 sigma underneath it.
Exactly. Yeah. The standard thing is to put a parenthesis and after it and say 2 sigma.
After the whole thing.
After
just
the whole
say.
thing. Yep.
Okay. I mean, that's all well and good for 2 sigma, but maybe not so good for something like this.
Right. We would have to control the number of digits there, like we do always do in the rest of our round. Perhaps just 2 digits, 2.3.
I think the 2 sigma could be really small.
Yep.
So we're really just combining this. Okay. So now the question is, what's the input? What's the representation?
Right. So perhaps an option. This is something like an option that says confidence level. Or
alternatively, we could do something where we say, where we go something like this. We go, I don't know what that is, something error 0.3, and then confidence. But it's not a confidence level. What you want is the sigma. The confidence level is something different, right? Because you could also have here paren 95% confidence level.
Right. But I mean,
you might want both of those.
Yes. I mean, those numbers represent the same thing, just different notations.
Oh, I understand that. But I'm saying that both in terms of input and in terms of, confidence level, 0.95, or you might want to say, what do you want to say? Variance or something? What is the term? What is the number of which 2? What do you call the 2 in 2 sigma? It's basically a variance.
Standard deviation.
No, but Stephen is referring, this is some sort of multiplier. So the whole thing 2 sigma would be the
I thought
deviation.
that means you're
but
two
the two,
standard deviations out.
No, I understand that, but what that means is this thing here represents two standard deviations, right? That's what this is. That's like the error value, and then we're saying, what does the error value mean?
Exactly.
And I mean, in a very naive way, we could call it sigmas, and the default is 1, and the default for this is 0.68 or whatever, right?
Mm-hmm.
I mean, I kind of favor, because I think both of these things, both confidence level and sigma, whatever the right term for that is,
mm-hmm.
are useful inputs.
Right. Yeah, we could certainly support both.
And then it might look like this, for example.
Mm-hmm.
And then whatever is given, I mean, if they're inconsistent, we have to deal with that and blah, 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 blah. But whatever is given will determine the output. And if we add one thing with a sigma and another thing with a confidence level, I don't know what we get.
One wins, as we do in other cases.
Fine. Okay.
Mm-hmm. Okay, so another thing that is important is that is to get properties of around objects.
Okay.
And I'm not sure whether to have an around value, which is what we had discussed long ago, following date value and entity value, or directly with information, which is being used now in more places, should be enough.
I think it should be an around value, because I think it's I think information is more, you've got a blob and this is what you're getting. I think this is more down in the details, I think.
Mm-hmm. I also favor that.
Okay.
Also because it will be able to work on things that are not directly arounds, like intervals, numbers, from which we could get an around.
I see, that's a nice idea. Right. Okay, handling of discontinuities and functions.
Mm-hmm. This is probably the most reported problem with around, which is fully based on on derivatives, on the first derivatives. And so if you compute things directly on discontinuity or something like that.
So what on earth do we do about it?
Well, this is the case in which probably we will have to smoothly transition to an interval-based approach, which I think is what users typically expect. Though, of course, it's very difficult to formalize in general.
Okay, but so the issue is, we're getting our error estimates from the derivative.
Yes.
But so this, if we did finite differences or something, then we could have a perfectly fine error estimate for the abs. The problem is it's not going to be consistent, because I mean the whole calculus of how these errors propagate is based on derivatives.
Exactly. That's why the documents that guide this calculus do not specify those cases. They just say this is too nonlinear. But of course, users still want to handle those.
No, I understand that. So what are our options? I mean, one option is to smooth this somewhat. I mean, if we did, okay, so how much smoothing? In other words, if we had a smoothing parameter in a round, okay, that said, if this is a point of discontinuity, then smooth by this amount, right? So in other words, if we literally took, a smoothing kernel to abs of X, see what I'm saying?
Yep.
And that's the definition, and that's all there is to it, so to speak. And whatever you smooth, you smooth. So in other words, we take this, and instead of that, I don't know, how will we do this? How do you do a convolution kernel on this thing? Do we say convolution? No, that doesn't work. How do we do this? You know what I'm saying? I want to just smooth it out by some amount.
I think I would multiply by one of the Windows functions.
Okay.
But I don't know which one to suggest right now.
There was a Hanning window or something. I don't know.
But I know what you mean. Now, there is also the problem, for example, that's why I chose ABS. There is also the fact that ABS is going to move everything to the positive side. So we cannot return an around. It has to be one of these asymmetric arounds in which the value is right on it.
Yeah, that's horrifying. Okay, but
exactly.
Let's try something like this.
No, it should be an X. We need to put an X somewhere. I mean, Let's see how it's.
Oh, I see. Rah! Not the right thing. I mean, in some sense, okay, go ahead. There's got to be a way to smooth this. But the problem is, if we smooth it, in general, it might go negative. I mean, it doesn't in this case, but in general, the general case of smoothing, it may not satisfy whatever bound you think you have. But I think that's the only kind of honest way to do it. It's just to define it, to put into the around a thing that says, if I hit a discontinuity, smooth in this way. Or you think there may be something better than that could be done?
Well, I mean, that would be an honest way to do it, but it would depend on how we smooth. So the result is going to be strongly dependent on how.
Okay, so what would you? I mean, the other possibility is essentially a table of this function at this discontinuity point does this with a round.
What I was thinking about is going to an interval. So if we change to interval arithmetics, then we do the computations in interval arithmetics and somehow go back. It is cheating because it's changing the rules of the game. But those rules of the game are better defined in all cases.
Yeah, except the errors won't accumulate correctly if we do that.
Yes, yes.
Look, I think a better thing to do would be to take some of these discontinuities and ask the question, first of all, we know something about what discontinuities exist in our functions.
Mm-hmm.
Right?
Yep.
We've inventoried that.
Yep.
So then the question would be to just ask, what would we like to have happen in each of these cases? And I think, let's just try a few different cases. I mean, ask the function discontinuity experts to say what they think should happen. And let's see what kinds of things, because this is, I don't know what happens with an essential singularity. I don't know what happens with all kinds of other wild things.
Mm-hmm. Right.
That's my suggestion, is get the function discontinuity people to inventory the possible discontinuities and say what they think should happen. And then we'll take it from there.
Okay.
What is this?
So this is a discussion that we had last week. I think it was Sanders who suggested that we do more computations for higher moments with a round. And so I was talking to the statistics team, and they mentioned that they have all these functions to manipulate moments.
Mm-hmm.
So in particular, there is moment evaluate, etc. So they can handle any moment. And they have 4 types of moments. So central moment, cumulant, and factorial moment.
And so what would this do? This would be a moment of and around, or what?
Yes, exactly.
Okay. That's interesting. I'm not quite sure. All right, let's just have a quick look here. More echo functions. What echo functions have been proposed?
No, I'm just asking because this has been a successful front in ILD. So I was wondering whether there is more to do there.
I don't remember. I mean, I think, look, the big thing with echo functions is evaluation tracing. And to me, there's a bigger story to evaluation tracing
mm-hmm.
that has to do with, basically our kind of causal graph formalism. Can we turn that into, in other words, you have an evaluation of an expression. It just does what it does. But there's also some kind of causal graph that represents what thing that is being used later in the evaluation came from an earlier evaluation. Am I making sense? And I don't know. I don't have a good theory of this, but I think there's some grand thing that we could do for evaluation tracing. I don't yet know what it is. And it's an old story, right? We have the trace function that was put in 1989 that was not very satisfactory. And I'm still trying to figure out how to do that properly. But you should go look and whether the oh boy, That's a comment on our live stream from Tom. Notice that list plot with a round is not saved to PDF nicely. Wow, that's bizarre and horrifying. Really? That it's not a vector graphic? That really surprises me. But we should look at that.
We will look into that, yes.
Yeah, thanks for the suggestion. It may be some particular one of the interval markers would have that characteristic.
Possibly.
Okay, just go ahead.
Attached coordinate is just a function that I always wanted to have, but I don't get to finish it. So
What is it?
hoping. So it's a function that receives an array of data and some ranges of coordinates, and it's able to insert the positions.
As a rule or something?
In various ways, we can specify whether it's a pair or a flat list or an association or a rule.
Yeah, I agree. This will be a useful function.
Mm-hmm.
I mean, the default version of it presumably would give part numbers, for instance.
Exactly, yeah. But you can specify ranges or dates, could insert dates, could work with your positions.
Right, so it's the thing that goes from a plain positional list to a thing that has coordinatization, which is why it's called attached. I mean, I'm wondering whether, whether the term coordinatize is that an interesting word, or does that scare us from physics?
I would love it.
Okay, fine. All right. Well, okay. If you think it means the right thing, I think that's an interesting word for this. It's more, it somehow is a bit more evocative than the attach thing. All right, we should probably wrap up here. For those interested, I in fact have another live stream in 10 minutes about history of science and technology. So that's more in the hobby channel. All right, good stuff. And it's we got lots more of these to go through, right? Hundreds and hundreds. Which month are we at so far? Are we?
This is February. We're almost through March in our
Of which year?
19. The months get shorter though.
Wait a minute, 19. Wait, no. It's in the 2000s. 2019.
Yeah.
Yeah. Okay.
That 19.
Okay. Fine.
After that, the months get shorter though, like 23 days each or something.
Because there are less functions.
Yeah.
Okay. Well, at least less functions that make it into this, the low-hanging fruit came early, basically.
That too. So,
okay.
Yeah, the percentage might drop and the raw number of candidates drops.
Right. Okay, sounds good. All right. Well, good stuff.